Good evening to all engineers. It's 7 o'clock and still we have only 4 engineers, only 3 I believe, 1, 2, 3, and still 6 engineers not appears on the classroom now. Anyway, we will give good evening and we will give only 2 minutes. Just I will give 2 minutes. 2 minutes and I will start. Exactly 2 minutes. 7:03. I will start. Okay. Allah Kareem, inshallah. Let us see. Good evening for all engineers. It's time to start. I would like to give some what you call it. Okay, what we have right now, guys. What we have right now, we have in my screen. I have first exercise. This is the one. Call it first exercise. This first exercise have 17 number questions. We need to solve, inshallah, most of them. This is 16 number questions we are going to solve. This is, I told the previous class, that's 2 printed hard copy. I believe all of you have hard copy now for this exercise. I wish so. Type. What else is other material we are going to go through it? Structure and slides. So we have exercise and we have slides. 01 first exercise and 01 first class session lecture. This is the first one. And make sure all of you have notebook, pencil, pen, whatever, and calculator. Why? We will go through the exercise, solve whatever we can together. I'm going to through my screen. I have pen, my paper, everything here. And we are going to have use the slides. Okay, guys? Clear? Please say yes or no. Clear, guys? Let's start. Very good. I am so much happy now. Thank you. Let's start, guys, now. See, this structure analysis is the first class I am giving to our classes. Why? Why I am already planned to give you, there is objective for sure, to give you a structure analysis, 3 hours, 3 hour classes, which all of them 6 hours, maybe it will go for 9 hours. Because actually the structure analysis is the key for your success in your exam. To your exam is the key to gain confidence, trust yourself, relief, feel comfort, and get the trust. What I mean here, through your exam, maybe the first questions you are going to find it is a structure analysis. If you don't know how to solve it, you are going to feel panic. You are going to be in a trouble mood. You are going to be confused a lot. No, I need from all of you control your emotion when you are dealing with your exam. Later through the classes, I'm going to give a brief and even detailed, it's not a brief, a detailed, how you are going to manage the 1 hour exam, your 1 hour exam, how you are going to manage the time. So we'll start from the first slides here. The first slide is telling you, see, this is my data analysis through all my experience due to this MMUP exam. I found out that 35% from the civil engineers, they are very weak in structure analysis. 21%, they are moderate. 42, they are telling 42.8 good, and 0, 0, very good, 0. Means what? I have 35% here and 21% here. That's meaning 50, almost 55% need to start from scratch. And this type of question they are very tricky questions, which you have in these slides. It's only they have 12 number questions from previous exams by everything, figures, numbers, values, everything. So that's mean what? Means if you practice this type of questions, you are going to memorize even. If you are lucky, the first screen in your exam, one of them. Wow. Once you get one of them and you know the answer, you memorize the answer. That's why we are going to solve by our own. You are going to feel confidence and you are going to feel happy and your best from first attempt. Right. Your strategy as a civil engineer, I said from previous exam, from previous class, I'm going to pass this one. Structure analysis. I am just giving this as to refresh your mind. What type of figure we have? What type of system we have? We have fixed end beam, fixed end beam, fixed end beam, both sides, A and C, fixed end, A and C fixed end. And this is fixed beam. Okay, very good. Go ahead. Okay, in your mind now, four questions. Number one, what is the structure analysis? Number two, why are you as a civil engineer studied structure analysis? Civil engineer without structure analysis is not a civil engineer. Civil engineer with a structure analysis. Okay. Number three, what are the knowledge areas should you focus on for our exam only? For our exam, we will not go for master degree in structure analysis. I am going to give you what exactly we are going to focus on. Number four, what are the structure elements should you focus on? There is this four type of questions. If we are going to answer them slowly one by one, and we will give examples and answer these questions together, you are going to be familiar and you are going to have refreshment your knowledge. Let us see. Number one, your strategy. Don't forget that by practice makes perfect. By study by your own and solve and using your calculation, your brain calculation. Don't focus too much in calculator. Try to enhance your calculation skills, because in your exam the calculator is built in your desktop. and you are going to be in hurry, always in hurry. You maybe you are going to be, I don't know, all of you the same mood of me. When I'm going for exam, I'm going for my exam, relax, relax, whatever is happen, it will happen. But not all of you the same. Not every engineers have the same mentality or mood. So try from now, exercise how to enhance your calculation skills. Okay, practice makes perfect. What is your strategy for studying structure analysis and get the questions answered right and get the score of it in your exam? I'm going to repeat it again. Maybe from 4 to 5, from 4 to 6 even. The number of questions means high score. And if all of you solve only these 6 numbers and the project management problems and the questions, for sure 100% you didn't need. So we are going to have 80-20 Pareto strategy. Means what? Try to study with 20% effort to get 80% result. This is, I am focused on it. Try to do 20% effort, we will gain 80% result. That's because we cannot focus in all civil engineering topics in 30 hours. So adopt this strategy as well. 80-20 or 20-80 means 20% effort, 80% result. So now start answer one question. What is a structure analysis? Structure analysis is the determination of the effect of the load. Okay, what type of loads, guys, we have? We have a lot of type of loads, but in our exam, we have dead load and the life load. Dead load and the life load. The effect of life load and the dead load on a physical structure and their components to check the stability of the system and safety of the system. Okay, very good. We will go for our screen. If you have any particular system, randomly, I'm going to draw randomly. Like, مثلا, we have randomly, whatever, this is a cross section. Your foundation. You need to calculate for me the reaction load on this foundation F1. يبقى root base. What is the root load base? The root load base I need from all of you to calculate for me now. How you are going to calculate for me the reaction load in foundation F? The reaction load, this is a connection between the system. This is a system, what I'm talking about. Any structure system. And this is a foundation. Connected with a particular connection here. Rigid or rigid? It's rigid. What is the reaction load? You, as a root base, start from here, going here, and this post, whatever, going here through, you can say slab, this way until you reach here, until you get here, until you get here, and you get here. How to determine all the reaction load? This is different today, but you have to define and determine the root base to see the impact and the effect of here. We will come back here. Structure analysis is the determination of the effects of the loads on a physical structure. We need to see the effects of the load. Very good. One-way slab and two-way slab. How the load is transferred from the slab to beams. You have a slab and a beam and another beam beam 1, beam 2, and you have here 2 meter, and you have here 5 meter. Slab 1. Slab 2, beam 1, beam 2, beam 1, beam 2, beam 3, beam 4, 4 meter, and 4 meter. يبقى here width and length is 4 meter. Here width is 2 meter, and here the length is 5 meter. For sure, 100% the load pass, it will come through this way. The loads, it will transfer from slab to the beam in this way. Why? Because this is one-way slab. What is the criteria to define the one-way or two-way slab? A length over a width. If more than 2, يبقى this is one-way slab. One way. Yes, 5 divided 2 is equal 2.5. يبقى this one-way slab. Come here is L over 4 equal 1. يبقى less or equal to. This is a definition of two-way slab. The two-way slab, this is the load, it will go in this direction. Clear, guys? Clear? Everybody is okay? Just tell me yes or no. Yes, please. Clear. Very good. Very good. Very good. Very good. Let us go for our exercise. So now we have exercise and we have slides. This is the exercise. The first slide is telling you what is the load, weight equal force equal M, mass multiply acceleration. Try to memorize this, the formula. Try to memorize the formula. Weight equal force equal mass multiply gravity. Try to memorize all the mathematics and the geometric. This one, try to memorize it. Okay, number 1. Questions number 1. Load pass is the one of load pass is one of the key considerations in structure design, and it is about how to bring the load acting on the building. As I told you, we are discuss in this example, whatever this random example, how the load it will transfer from this structure system to the foundation. Okay. So now the load pass to the building facade, to the ground and the foundation, to the column, to the beam. Take few seconds, guys, and give me the right answer. By the way, I need all of you to check your score after the session. Means if we succeed to solve 10, 20, whatever, how many numbers of questions we are going to answer, try to score yourself. See how many answers you already correct and how many answers you already false on it, and check your score. The answer is, let me see, check. Wow, all of you Correct answer. B, B, B. Very good, very good. See this, it's very simple type, a very simple type of questions. Type. So take all the effect of the load. If even you have multiply stories like 60 floor, I will start from the rooftop until we reach to the ground foundation, whatever the type of foundation, pile or isolated or raft or whatever, and the ground. You the answer is B. Type number 2. Questions number 2. Which of the following? Which of the following? Raise hand. Okay, raise hand. Tell me whatever. I am going to raise hand. What is the problem? Shikisa, I am going to unmute. Tell me what is the problem, please. Hello. Shakisa. Hello. Tell me. Okay, no problem. I see, it seems. Okay. So now, which of the following? Number 2. Which of the following reinforcement concrete beam slab floor would be considered an effective two-way slab? Guys, take your time, and we have system A, we have system B, we have system C. We have system for each one here, this system. We have system A, this is a system A, and we have system B, and we have system C, and we have B. D. We have slab in A. How many slab we have? At the 1 slab, 2 slab, 3 slab, 4 slab. How many beams we have? We have 1 beam, main. 2, the second main beam, 2, 3, 4, 5, 6, 7 beams. We have 4 columns. We have in B 2 slabs, and we have 1 beam, 2 beam, 3 beam, 4 beam, 5 beams. We have in C 1 slab, and we have 4 beam, and we have 4 columns. We have in D how many slab? 1 slab and 4 beams. Type. In A will be is wrong. All of them one-way slabs. One-way slab, one-way slab, one-way slab, one-way slab, one-way slab. By what? By our engineering sense. Yes, he don't give you any dimension, but you have to enhance your engineering sense. This is what I'm telling. Enhance. A D with C. For sure, 100% the answer is C. I cannot hear voice. You cannot hear voice. I will. Okay. You cannot hear voice. You cannot hear voice. C. All of you or only? Okay. Everyone type. Tab. You can hear the voice. I will make it again. I will make it again. 1 minute. You hear now? Please type or whatever. You are hearing now. If you are not hearing, because maybe something wrong in your system. Because I cannot hear you as well. Shakisa, did you hear me now? Please type any whatever. I am trying to. I am already on my system. Any problems, guys, for all of you? I believe all of you can hear me. Please. Clear here. Okay, no problem. See, check, Shakisa, please. Check in your system. Okay, check in your system and rectify yourself, please. Now. Okay, very good. That's meaning okay. Right. So the answer is C. How many score now? 2/2. 2/2. Very good. 2/2. طيب, let us go for number 3. Okay. Consider question number 3. Consider the framing and the structure detailed. We have a cross section here, guys. We have a cross section. This cross section this is in the slides now in the screen. We have cross section. It's not elevation. It's not plan. It's not side view. It's a cross section. Okay, you have a cross section, and you have a strap, and you have stud, and you have beam, and you have column, and you have foundation. Consider the framing and the structure detailed showing the load path for this diagram design should be what? take few seconds and please give me the correct answer. Take few seconds, please, guys. Okay. Okay. See, all of you. Oh, very good, very good. It seems all of you very in the right track. In the right track. 7, 8, 8. Let me check. 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 Oh, let me check. D. Wow, fantastic, guys. All of you correct. Oh, D. Oh, very good. The answer is D. The load, it will go from stud to strap to beam to column to footing. That's it. Very good. You have 3/3 now. Very good. Very good. Let us go for our slides. What is a structure analysis? First question now, the three type of questions. Answer, you already answered them now. It's what is the structure analysis? Structure analysis is the determination of the effects of loads on physical structures and their components. See, guys, by answering these three questions correct, you understand what is the structure analysis now. Sometimes we have BEB structure system, and while you have a project, warehouse, a project, and the system is BEB system, and while you are having a project, you have to determine the reaction load by supplier. Reaction load. The supplier, if he don't have a structural engineer, he will he will fail to give you the reaction load. Number two, question number two. Why are you, as a civil engineer, studied structure analysis? Why? Why we studied structure analysis? What is a structure analysis? We knew it now. Why? A structure analysis is important because it can evaluate whether a specific structure design will be able to withstand the external and the internal stresses and the forces expected for the design. Now we will discuss about equilibrium and stability. While design, we need to know the force acting for sure, 100%, especially for in design. But for BEB structure system, what pre-engineered structure warehouses, the structure analysis, sometimes in tendering stage, they are giving a particular standard design. And through execution, once you have the execution, is telling you in a contract condition, you have to revalidate the design. I'm just, from validation design, you are going to supply, you have a BEB supplier, like a Zamir or Kirby or something like that. You are asking him, give me the reaction load, please. He will not give you the reaction load until you sign a contract between him and, anyway, while design, we need to know the force. Correct. Very correct. Very good. Type. Why are you, as a civil engineer, study structure analysis? To check the stability and safety of the system and evaluate, are this system, due to this load, it will be slides or overturning or uplifting. We have three check-up for any structure system. Three check-up. First check-up is sliding. Are this structure, maybe system, due to this load, maybe it will be slides or overturning or uplifting. Three check-up. Okay. So now this is number two. Structure analysis is important because it can evaluate. Can evaluate. Let us go for a exercise number one. This question number 4 is to evaluate. Now, let us evaluate. Referring to the figure, what is the load combination produces the maximum uplift on footing? Equilibrium, guys. Let us talk about equilibrium after these questions. We are going to talk about equilibrium after this question. Answer these questions, please. Number 4, referring referring to the figure, what is the load combination? Uplifting, where is the foot? He's telling you footing A. Uplifting means what? What's the meaning uplifting? What's the meaning uplifting? I will show it you. All of you can see my screen correct, please, guys? I wish all of you can hear me and see my screen and whatever I'm doing now. We have uplifting. First, sliding. Sliding means you have a particular retaining wall. Uses load. You have a load here. Uses load. Maybe this is move in this direction. Slides. This retaining wall. Maybe slide in this. You are sliding. What about you have a building like that? Uses load, wind load. Maybe the rooftop. This is the rooftop. Uplifting. All of them, it will be uplifting. Remove from in this direction. Or overturning. Overturning, you have a particular equilibrium system, any equilibrium system, and you have a load, external load, and you have point support point A, support point B. Due this load, this body will be overturning about B. That's meaning it will be overturning like this. This overturning point. So sliding, uplifting, and overturning. Okay? Right. Very good. Let us go for our. What is the combination then, guys? Let us see the answers. We still have 4 engineer not answer. Please participate, guys. Try to answer. Try to answer. See now, we have dead load, life load, and wind load. Uplifting means this direction. This body, it will move in this direction. That's mean what? The combination. Take moment here at foundation foot, at the footing A. That's meaning dead load, life load, wind load, both, all of them in one direction. Make moment in the same direction. That's mean what? The combination is dead, life, the plus wind. See, let me see the answer. D, very good. D. Oh, fantastic, guys. D. All of you correct. D. Correct. Very good. Let us go for our. Okay, number 5. We'll start number 5 later. Let us see now. Structure analysis is why are you as a civil engineer study structure analysis? Structure analysis is important. Blah blah. We talk about this one. Number 3. Okay, what are the knowledge area should focus on? What's the knowledge area now? We will start now. What exactly is the knowledge area? Now we study, in general, structure analysis from question number 1 to question number for question number 1 to question number 2 is in general. Now we'll go more specified. So now, shear force, normal force, and bending moment force. 3.1. 3.2. Shear forces, normal forces, and moment diagrams. 3.3, statically determinate and statically indeterminate structure elements. We are going to discuss about them. Stability of structure elements. We just started to discuss about stability now. From question number 2. Deflection and the slope of structure elements. Okay, very good. We'll go for equilibrium. First, let us have what is the equilibrium. We will discuss now about point number 1, equilibrium and the equation of equilibrium. What's the meaning of equilibrium? Anybody. This is anybody. You have a particular body. We call this body statically under equilibrium state. What does it mean? You have, for example, force acting inclined in this direction. This is P1. And another force acting in this direction, vertically, B2. Okay, this is a Can you explain 1 and 2 question once again? I was not hear the voice. Balanced force. Okay, I will come back to number 1 and 2 later, but just only let us focus in this area now, and I will come back to it within maximum 5 minutes. Okay, we call this body is under equilibrium. For sure, 100%. These acting forces on a body, what you are expecting due to this load on the body, for sure 100% there is what? There is reaction load. For sure 100%. You are R1. And for sure 100% R2. Okay, for sure 100%. And the weight of the body itself, and W. We call every load have its own concentrated and say concentrated point. At the point, this point is alpha. This is with X and Y. Inclined with alpha, and B2 is vertically, and the reaction 1. And for sure 100% there is force here, resist B1. If you have B1, you have B1. Decompose this force into 2 directions. B1 what? B1 cosine alpha, and here is B1 sine alpha, and B2 and R1. So we said this body is under equilibrium if we have 3 equations. Sigma x, all the forces in x direction should be 0. Sigma y, all the forces in y direction, in vertical direction, should be 0. Sigma moment for all the forces for a particular point, like for example x, like for example z, this should be all the moment for all these forces equal 0, including reaction. We have reaction, it's a load. This reaction developed due to the external load. If the body it will move means for sure 100%. If move, يبقى sigma x is not 0. If it's move, there is a moment. يبقى this, if move in this area, in this point, if this point, for example, 2 point number 2 and point number 1, if in point number 2 overturning, this meaning the sigma moment is not equal 0. If uplifting in point A, that's meaning uplift, there is uplift force here, that's meaning sigma y is not 0. يبقى to have equation, the equation, 3 equation of E O E equal 3. We call it 3 equation of equilibrium. If the 3 equation of equilibrium, all of them 0, 0, 0, means what? This body is stable and under equilibrium state. And a structure system, we adopt and we have the standard. We consider any structure system is under equilibrium states. Means what? Any beam, any frame, any truss under equilibrium, statically under equilibrium. Determinate, indeterminate is different story. But let us see statically equilibrium. That means what? The 3 equation is equal 0. يبقى sigma y is equal 0, sigma x is equal 0, sigma m is equal 0. Clear? From this point, we'll start to structure analysis about supports, systems, reactions. What we will see now? Let us see. Don't forget about that's 3 equation of equilibrium. Okay. I will go back for question number 1 and 2 in a hurry. Okay, guys, because one engineers. Don't worry, guys. We have enough time, and inshallah, we'll solve. Number 1. Question number 1. Load pass is one of the key consideration in structure design, and it's about how to bring the load acting on the building. Any loads start from high level, for example, 3 floor building, ground plus 3 typical floor. Start from the rooftop until the loads coming into through the foundation, and from foundation to soil. So the load pass is what? The load pass is all the weight of the building through ground. We need to go put it through ground. So to the building facade, to the ground foundation, to the column, to the beams. For sure, 100% the correct answer is to the ground and the foundation. Okay, guys? Number 1 is already clear. Number 2, consider which one is one-way slab and two-way slab. One-way slab and two-way slab. One-way slab, we have lengths, we have widths. Any slab, the ratio between its length over its width more than 2, we consider it as one-way slab. Means what? Slab with 1 meter width and 3 meter length. The ratio is 3 over 1 is equal 3. That means what? This is one-way slab. Type another slab, 1.8 length width and 3 meter length. That means what? Length over width. 3 over 1.8 less or equal to. That's meaning what? Two-way slab. So that means what? From our sense, A, B, C, D. Which one of them have two-way slab? This is one-way slab. As our engineering will consider one-way slab, one-way slab, one-way slab, one-way slab, one-way slab, one-way slab, two-way slab, one-way slab. So the answer is C. I believe now I already clear for 1 and 2. Noted? Tamam, alhamdulillah. Okay. Right. Let us go for our slides again. Here. يبقى shear force, normal force, and bending moment force, and shear force, normal forces and moment diagram, statically determinate and statically indeterminate structure system, stability of structure elements, and deflection and the slope of structure elements. Very good. Question number 4. What are the structure element should I focus on? Okay, I am going to focus in beams, trusses, frames. Okay, very good. We'll stop in this point. 3 and 4 will come back again, gently. Let us go for our exercise. Number 1, 2, 3, 4, solve it, correct? Number 5, guys. We'll start from number 5. If all of you solve these questions correct, invited for 5-star hotels is open now. You are invited, all of you invited for 5-star hotel dinner from my book. All of you try to solve this question correct. I will give you 2 minutes, 13 seconds. Read this question, try to solve it, and tell me what is the maximum load that the crane can lift without overturning is most nearly. Equilibrium, guys, equilibrium, sigma moment at any point should be 0, which I just tell you now. Try to solve this question by your own in your notebook. Now, take 2 minutes and 13 seconds. Tell me your answer, please. Okay. What is the correct answer, all of you? Still, take your time. No big deal. I am going to prepare myself for this question. Take your time and no panic. When I say 2 minutes 13 seconds, I am just trying to make you excited and challenging. 5-star hotel waiting for all of you. Start 1st of July, I believe the hotels will be open for dinner. Assume you have these questions in your first slide, first question in your screen, in your exam. And it's come like everything with values, numbers, everything. So as much as you can memorize, you are going to be perfect. And as much you solve this question by your own, you are going to be more perfect. Solve it, guys. Oh, come on. All of you 4/4 now. Guys, yalla. 4 over 4. Good, good, good. Inshallah, everything will be okay. Equilibrium, guys. Overturning, overturning, overturning. Let me check, let me check, let me check. Wow, A. Oh, oh, A. Okay, let me check. Let me check, let me check, let me check. Wrong. Guys, I have tower crane with 7,000 pound counterweight. 7,000 pound means this is 7,000 pound. 7,000 pound divided 1,000, we call it 7 kips. يبقى 7 kips here. 7 kips. This is what we call it counterweight. 7,000 pound divided 1 kip equal 1,000 pound. You have to know now, start now to memorize and refreshment. الباوند 1000 pound equal 1 kip. Okay, very good. And counterweight A is used to pick up loads with 15 boom extension. That's meaning the boom is 15. The CG of the boom is far away from the post 5 feet. That's mean what? Here we have 5 feet. I will check your answer right now. 5 feet. Okay, this is 1,000. 1,000 divided 1,000, 1 kip. And we have here 10,000. 10 feet. Let me check your answer. Let me check your answer. Let me check your answer. Can you show the equation again? I will show, don't worry. I will solve this question and I will show to you the equation. 4A is wrong, guys. You are failed to have the 5-star invitation from me. That's okay. Let us see. So I need to know. Okay, let me check now. Let me check the last. D. Oh, perfect, guys. Perfect. Gobi, yes, this is correct answer. I am appreciating you. Correct. Let us solve it for all of you. Okay, let me solve it, guys. Right. Let us see. We have 1 kips here. This is 1 kip, and we have B. B is unknown. I don't know it. I need to know it. And we have the post of the tower crane is 3,000. 3,000 divided 3, يبقى 3 kips. Here يبقى 3 kips. 3. And we have the foundation is 20,000 pounds. That's meaning 20 kips. يبقى here 20 kips. And here is 3 kips. And we have 3 points at the point number A, point B, and point C. What is 3 point? 3 point, this is a foundation contact with the soil. In your opinion, due to this load, what is the overturning point? Point A, due to this load. This load, it will be exceeds the limit. The system, it will be overturning in this direction. This is the way of the overturning movement. The section, all the section will collapse in this direction. Where is the nearest point for overturning? Point A, wala point B, wala point C? Please give me your opinion in the chat now. Give me A, wala B, wala C overturning. Due to this load, all the system, it will fail, have a failure on the system in this direction. What is the arrow now? The arrow now. C, correct. the nearest point that this system it will be overturning in point C, correct? This is a point. This is a point. This is the overturning point. The system can, yes, can fail here, but due to what? Due to what? Failure in the system. If the connection between the post and the foundation is not designed as resist the load, maybe yes, failure it happened here. But he told you overturning. He is more specified in the question. Mean overturning means what? Equilibrium. Equilibrium where we will take a level. Equilibrium, that's meaning what? Here is a weight. Whatever forces in the right hand, where is the right hand now? At the right hand and the left hand. You have forces in the right hand and you have forces in the left hand. صح? Correct? This is right hand and this is your left hand. You have B1 and 1 kip in this line, in this side. And you have 7 kips and 3 kips and 20 kips in this side. Means what? Should be the resultant of the moment due to these forces in a point C should be 0. Means what? Means B1 moment in this direction. See صح كده or not? ادي 1 ادي first moment B1 multiply what? Distance اللي هي 12 اللي هي 10 plus 5 minus 3 because of this distance is 3 feet. 12 15 minus 5 plus 5 is equal 15 minus 3 is equal 12. يبقى B1 multiply 12. What else? We have 1 kip plus 1 kip multiply what? Multiply 5 minus 3 يبقى equal 2. This is the summation of the right hand. What is the left hand? Left hand we have 7 multiply what? Multiply. We have this distance is 7 feet. Let me check. 7 feet. 7 feet multiply يبقى 7 feet. 7 feet plus 3 يبقى 10. يبقى 7 multiply 10. Correct. Number 2 what? 3 يبقى 3 multiply 3. What else? 20 multiply 3 يبقى this is the moment from the left hand side. Should be both should be 0 to have equilibrium. Means what? Should be the right hand left hand equal each other. From this equation I can get till B. يبقى the equation telling you what? The equation is telling you B. B1 multiply 12 plus 2 equal 70 plus 23 multiply 3. 23 multiply 3. El B will equal 11.41 kips. If you calculate now, all of you, you will find out that cell B equal D. Correct. The answer is D. Very good. You will find it out 11.41. Means what? If you have a load equal 11.42, this system it will be overturning in point C. Right. For factor of safety and we will take it. What is the most nearly answer is 11. Let us see our option. 11. Let us see our option. here. Option number A, 7.5 is wrong. Option number B is 10.75, near. Number C, 13.25 keeps wrong. Number D is 11. Most nearly. يبقى most nearly I will take 11. The answer is 11. Now it's clear? All of you please tell me is clear or not? All of you, let me check. Clear. Okay, very good. Alhamdulillah. طيب. Now we'll come back to our, the answer shall be more than 11. The answer shall be, لا ازاي? How come? Again guys, Anwar, please try to, so the answer it will be 11.41. So the answer, if 13.25, that's meaning for sure 100% this system it will failure, have a failure on it and overturning in point C, as I discussed with you. The answer shall be more than 11. The answer shall. Yes, you got it now? Okay. Okay, very good. So, alhamdulillah. Again, we'll come back to our structure. So now, what are the structure elements should I focus on? Beams, trusses, frames. Today we'll discuss about beams. Beams. Okay. And we'll discuss about shear forces, normal forces, and bending moment forces, shear forces, normal forces, and moment diagrams, statically determinate and statically indeterminate structure elements. I will just give 5 minutes as relax, and we'll come back again after 5 minutes exactly. Okay, 5 minutes, guys. Please, just 5 minutes. 7:07. I'm come back. Hello guys, welcome back. Let's start now. Discuss about beams and shear force, normal force, and the bending moment forces and diagrams. Okay. First, loads. We discuss about loads acting on a system. When the loads acting in a beams, we have a standard assumption of all the elements. For example, supports. Supports. First support we are going to discuss about it. It's hinged support. Hinged support indicated like that. This is the indication of hinged support. That meaning we have support. We call it hinged support, or what we call or bin support, or bin support. Due to the load, you this is a hinged support as I told you, and this is we call it roller support. Roller support. This our first structure system you are going to study is the beam. This is beam, simply supported beam. This simply supported beam. Beam. Beams due the loads B1, B2, whatever the loads system acting, there is a reaction. Every action have a reaction. Due to the system, we call it hinged support. We only have one reaction, standard. This is standard. You buy R1. R1 is vertical to the level, the X direction. This is a reaction. Okay? If even the loads here, here, inclined, we have two reaction, R1 and R2. This is the way, always. If even the beam inclined like that, and this is the support, see, this is the support, and you have another support, roller support, the reaction due to this load, B1, it's in this direction, at 1, 2. يبقى R1, R2. See, the way of the reaction on the hinged support, two reaction. What about the reaction on roller support? Always perpendicular to the plane of movement. This is the perpendicular. That's meaning R1, R2, يبقى this R3. R3. طيب. Due this beam again, another beam. This is hinged, and this is roller support, and you have here 10 Newton, 10 kilonewton, 10 kips, whatever, 10 kilonewton acting on this beam. This distance from here is 6 meters, and here is 2 meters. How many reaction? How many reaction, guys? 3 directly. This is a simple supported beam. I have 2 reaction here. Assume this A and this is B. I have what? I have Y, B. First reaction. Second reaction, X, B. And Y, A. حلوة. Y. How many reactions then? Adi 1, 2, and 3. Okay. Did you know them? All of you guys, did you know them? Now, did you know them? Tell me yes or no. I need all of you, yes or no. Did you know them? Yes or no? Yes or no? Let me see. Did you know them? No, I don't know them until I use the equation. No, guys, this we call it unknowns. We still apply the equations, we will get no. But until now, I don't know them. I don't know them. I have to apply the equation sigma x is equal 0, sigma y is equal 0, sigma moment at any point equal 0, because I am consider this statically under equilibrium. Clear? I have three unknowns. I have three unknowns. Is moment 2, of course, three equation. I call three equation. Sigma x equal 0. All the forces in x direction should be 0. Sigma y, all the forces in y direction in vertical direction should be 0. And sigma moment at any point should be 0. This is the three equation of equilibrium. خلاص, I got to know them. Three equation of equilibrium. How many equation? Three, guys. خلاص, I know them now. Three equation of equilibrium, sigma x, sigma y, sigma moment. طيب, how many unknowns? How many unknowns? I have three unknowns. يبقى three unknowns. That's mean what? يبقى these three unknowns. Three unknowns and three equation of equilibrium. 3 minus 3 is equal 0. 3 equals 0. That means what? This simply supported beam is statically determinate. Now we discuss about reaction, supports, type of supports for a simply supported beam, equation of equilibrium, unknowns, and so now if the unknowns equal the equation of equilibrium for any structure system, we call it what? We call it statically determinate. Determinate. Statically determinate. So now the definition now of statically determinate and statically indeterminate structure elements, we discuss it right now. I will give another example. Another example. Slowly. We refresh all our knowledge. We talk about two supports. I am going to talk about the third support only. We will discuss about only three types of support. The third one is fixed end. Fixed end. Fixed end support. What does it mean, fixed end support? Fixed end cantilever beam. It will be like that. This fixed end. So we have hinged, roller, and fixed end. Fixed end, we have two reaction here, 1 and 2. We have 1. And we have here due to any loads acting on the system, B. We have 3 reaction here, 3 reaction. ADI A, B, يبقى Y, A, and XA, and moment, MA. This moment, this force X, this YA force is 3 reaction. So now I have 3 reaction. Okay. Right. So for this system, roller support and fixed end. And you have load B1. This load is 10 meter, 10 kilonewton, 2 meter, 2 meter. A, B. C. Let us discuss about this system. This is a beam, yes. One side is fixed end and one side is roller support. How many reaction, guys? Unknowns. How many unknowns? How many unknowns? How many unknowns? Reaction. How many unknowns? I don't know them now. YA. YA perpendicular to the YA. What else? YB. XB. And MB. يبقى دي 1 2 3 we have 4 unknown. 3 equation of equilibrium. 3 equation of equilibrium equal 4. 4 minus 3 equal 1. Means what? I cannot solve this structure system using 3 equation of equilibrium, and this system is statically indeterminate first degree. يبقى now unknowns, equilibrium, supports, reactions. I got to know now. This system, I cannot solve it. In your exam, will never, ever, never, ever, never, ever give you indeterminate problem. Never. He will give you all the answer, all the questions with fact of determinate structure system. Let me check your. Let me check your share, what we have. 4. Very good. Type. Now, to solve this type of questions, you have maybe he will give you a support or give you a hint to solve it, which you call it hinge, or you have to use another system, which is not equation of equilibrium. We call it influence line, moment distribution, a lot of A system. In our class, we are not focusing in this area. We are going to focus in this limit. Determinate and determinate. To solve this question, he will give you a hinge here. He can give you a hinge here. Tell you a hinge here. There is hinge. Hinge. Why hinge? I have another equation. Sigma moment at D equal 0. يبقى sigma moment, يبقى 3 equation of equilibrium and plus sigma moment, especially at D equal 0. يبقى 4 plus 1, يبقى 1 plus 3 equal 4 minus 4 0. خلاص بقت ايه؟ This system is statically determinate now. خلاص solve it now. He will give you a hinge. Never ever in your exam give you a structure analysis problem with statically indeterminate. Clear? Let us talk now about what? About normal force, shear force moment. Okay, I will give a very simple question, example, and I will solve it to you. Clear, guys, until now? Please tell me yes or no. Because structure analysis is very important, all of you. Please, guys, clear or no, or I can repeat, no big deal. I can repeat, no problem for me. I guess, okay. I guess so, okay. Yes, very good. Thank you, very good, very good, very good. Now, let us go for a particular example. Let us go for this example. You have a simply supported beam. Simply supported beam. See, guys, simply supported beam. hinged and roller support. And you have inclined force equal 10. See, I'm giving you 10 kips. This angle is 30 degree. And this is we can say 6 feet and 4 feet. A, support A and support B. What is the normal force? What is the shear force? What is the moment force in a particular point C? C is far away from this end by 3 feet. I need section C. I need all of us now with me, and I'm going to show it to you now. Calculate and estimate the normal force at section C, the shear force at section C, and the moment, bending moment, moment force 8A at section C. Okay, to solve these equations, we have to get all the unknowns. I have reactions now. Okay, very good. That means what here? First of all, this inclined force. What does it mean inclined force? Means I have to decompose in these two directions. Why is not red? Okay, anyway, this is 10. 10 what? 10 sine. 30. And here is 10 cosine 30. If you have any inclined force, this inclined force at B, and you have theta, this force is B sine theta, and this force is B cosine theta. This is the way. Okay, let us draw the free body diagram. Free body diagrams mean what? I'm going to remove all the supports and I will remove all the reaction on the body. Means if I will leave this body in the air, will not move, because determinate and indeterminate difference ones again. Shear tab. Okay, guys. Very good, very good. Let us solve it. This is your very good, very good. Determinate and indeterminate difference ones again. Determinates means total number. Determinate, I'm talking about determinate. Total number of unknowns equal equation of equilibrium. If I have unknowns, the reaction equals 3 and equation of equilibrium equals 3, يبقى that mean what? يبقى this is statically determinate. If unknown as a beam hinged and another support hinged, how many reaction now? And this is force B1. How many reaction now at 1, 2, 1, 2. How many unknowns? 4. 4. Equation of equilibrium 3. 3 minus 4, 1. That means what? This system is statically indeterminate first degree. Why first degree? Because 4 minus 3 equal 1. Type another system. Adi 1. Continuous beam. Hinged. Hinged. Load. Load. And I have A1, B and C. How many hinged support? 3. 1, 2, 3. How many reaction? I have 2. 2 means what? I have 6 unknowns. 3 equation of equilibrium. 3 minus 3 means what? I have system now statically indeterminate third degree. Clear, guys? Clear? Now the difference between determinate and indeterminate: how many reaction, how many equation of equilibrium, how many unknowns. I can get them by the equation of equilibrium. How many unknowns? I can get them by using the equation of equilibrium. This is the difference between statically determinate and statically indeterminate. Clear? Let us go for our example. You have the calculator, you have pen, you have notebook, and give me the free body diagram. Free body diagram. I have here what? I have a force, reaction, sorry, Y, B, and X, B, 2 reaction. And I have here what? I have YA. And I have force acting here is vertical. 10 sine 30 is equal what? And 10 cosine 30. If you come back, 10 cosine 30 equal 8. This is 8.67 kips. And I have 10 sine 30, 10 multiply sine 30 equal 5 kips. 5 kips. Type. The first equation I have now, the first equation, sigma x is equal 0. Sigma x is equal 0. Sigma x equal 0 means what? Means xp equal what? Equal 8.67 kips. This is the first equation. What about the second equation? I get the first unknown now. xb is equal 8.67. Clear, guys? Everything is okay now? Hello? Okay, clear. If anybody need any queries or questions or whatever clarification, just say, write it down in the chat. Okay, we have sigma y equal 0. Okay, and I have another equation, sigma moment at any point is equal 0. At any point is equal 0 means what? If I take moment at sigma A is equal 0, I can get what? I can get YB. Let us have this equation. Sigma moment at any point is equal 0 first. يبقى دي first equation. يبقى sigma moment should be sigma moment at A equal 0. I will get what? I will get YB. Sigma moment at 0 equal 5 first, 5 multiply 4, because this is a 5 here, distance is 4, you minus 5. Why minus? Later on I will tell you why. Minus 5 multiply 4, okay, plus another equilibrium, guys. Make sides, both sides, LYB plus 10 equal, sorry, should be equal 0. This is the equation. يبقى الYB equal 20 over 10 equal 2 kips. يبقى الYB equal 2 kips, and we have here 6.8.67. And I have sigma y, the third equation. This is the second equation. Add 1, add 2, add 1. And the third one is sigma y equal 0 means what? Means y a plus ال2 اللي هي YB equal 10 equal 5, sorry, equal 5. Means yes, because this is a vertical now is equal 5. That means YA equal what? Equal 3 kips. I get all unknowns? Yes, I get. This is the third equation. I get all the unknowns now. This is equal 3. I get all the unknowns now. Very good. So now all the unknowns, I get them by using what? Using equation of equilibrium. If this support hinged, means what? Two reaction, I cannot solve. I cannot solve this beam with 3 equations. Let us have the, what is the diagrams? I am going to draw diagrams now. From these diagrams, I am going to have forces. First diagram is normal force diagram. Normal force diagram. Always from your side, you will start to draw from the left hand side. This is the left hand side. This is the left hand side. You always start, this is normal force diagram. You will start from the left hand side. Type. Any force here, normal force means what? Perpendicular to the section. يبقى add section A. Any perpendicular force? No. Go straight, 0, 0, 0, 0, 0, 0, 0 until you reach to the point D.